Well, I've already set us up for success with one of the ways. And this is common, I shouldn't say one of the ways. Basically, the way that is common between the two methods that I'm going to talk about next. What I did was I called this Win32 handmade.cpp. And my expectation is that somebody else will come along at some point and create Linux handmade.cpp, right? That someone's going to be me, but like I said, in a larger project, it would probably be the platform expert for Linux, whoever's job it is to make that be running. Now, the way that this will work then, right, is that the Win32 specific code will go into these files that are marked Win32, and there might be more than one. It doesn't just have to be one. Multiple files with Win32 underscore, and all of the Linux code will go into Linux underscore files. Now, the way it will work from there on is we will create a single shared header file that'll be called handmade.h, right? And this single shared header file will basically include the operations that the platform layer is supposed to be able to perform on behalf of our cross-platform code, right? It will create basically an API in this, it'll sort of create our own platform abstraction API in this header file. And all of our platform non-specific code will call into it this way. So basically, let's say, have something where we want to load a file. We will type something like load file, right? And there's a name for the file. This is not the actual API we will use, but let's say we have that. We will call this load file. And oftentimes what I like to do is call it platform load file so that we know that we're asking the platform for something. They typically get prefixed, right? There will be one definition of that here, right? And it'll do the load. I guess it's got to actually return something probably, blah, blah, blah. But anyway, you get my idea. There is a platform API here. Then what happens is that API exists both here, right, inside the Linux version. And so in the Linux file, right, I would do, this implements the Linux file loading, right? And then in the Win32 version, I would do the same thing, right? I would basically have this for the Win32 version here, okay? So all that happens now is when we're actually writing platform non-specific code. So let's say we are in handmade.cpp, right? I open up my handmade.cpp. No, I do not want that. I want that. There we go. In handmade.cpp, I've got some stuff. I don't know what function this is, but I want to load a file. And I don't want this code to be relying on Windows because I don't want any more of the code that we ever write to be relying on Windows. I want it to be completely cross-platform. I am just going to call platform load file with the file name, right? I'm going to ask it to load that, and it's going to give me back the file contents like that, okay? And this is the structure that we are going to use from now on. So if you imagine this is our main loop or something, I don't know exactly what it is. This is how that goes. Then what I'm going to do is I'm just going to call into that from the platform layer. So once we have started things going, right? Once things are running, I am going to call in here when we're actually up. I don't know where, we're going to clean up this thing in a second here, but so after we do, whatever their sound buffer, who knows, we're going to call this main loop thing, right? We're going to call it from in here, okay? And I have to obviously include this file, so let's do that here as well. This is something I'll talk about in 1 second as well, handmade.cpp. And I will go ahead and include handmade.h in here, like that, and I will compile. Okay, so in here, we have to actually pretend that we implemented that, at least a little. So now what I want to show you is basically, I'm going to talk a little bit, well, actually I'm going to talk at length about what I just did there, but in the intro, just before I go into that, I'm going to show you exactly what I mean now so you can be 100% clear on that. So basically what's going to happen is we start off in the platform-specific layer. Right? The platform-specific layer is still controlling just like it was when we were Windows only. It does all of the Windows startup stuff that it was going to do, right? It does the same things, but then when it's ready to actually do game work, right? When it's ready to do game work, it calls into the platform non-specific layer of our code where all the rest of our code will live basically from now on. Then, whenever it gets to the point where it needs a platform service again, when it needs to do something that only the platform knows how to do. File I/O, network I/O, graphics display, whatever it happens to be, then it is going to go ahead and call out, right? That call out then goes right back in to the platform layer. That platform layer fields the call, does the Windows-specific, Linux-specific, Mac-specific thing here, whatever that happens to be, returns back, and things continue as normal, okay? Now I said I was going to talk about 2 ways. Right now I'm talking about just the basics that is going to be shared between both ways. This is, I would argue, the more common, more modern way of doing cross-platform code. I don't think a lot of people advocate for doing the first method that I talked about anymore. I don't think you would see a lot of people strenuously arguing that no, it's better to have all these if-defs throughout the code. I think this, what I said right there, would be relatively uncontroversial. You never know, programming things somehow seem to be controversial even when you think they wouldn't be, but I suspect you would not get a lot of people going, no, you need pound if-defs everywhere, that's fantastic. So, now we get to the 2 possible ways of using the technique that I just described, which creates sort of 2 different philosophical camps for how the platform code should be written. I fall into the latter camp. I think most people fall into the former camp, so I am not going to tell you that one of these is wrong and one of these is right. I am going to tell you which one I prefer and why, but I would recommend that you think about them yourself, try them yourself if you don't have experience with them, and decide for yourself which one you would like better and do that one, because I do not have it is not an ideological war with me. I am not going to go 50 rounds with someone telling them that one is better or one is worse. I can just tell you which one that I prefer, and then you should make up your own mind about which one you prefer. So, first, before I go into those 2, I'm going to tell you a little bit what I did with the build here, because it's a little crazy, and I realize that. This is something that will be highly controversial, I guarantee you, but again, not even arguing for it, just telling you how I code. Normally, the way people like to do build environments is when you have more than one file, which you almost always do, you start adding those files to this CL line here. And now most people actually have a much more complicated build system than this. So actually what they do is they have like a whole make system that lists a bunch of files and then figures out what their dependencies are and which ones have to be rebuilt, and then calls CL multiple times once for each file that has to be built, or all these other sorts of things. Many different things. You can spend forever looking up build environments. If you are interested in build environments, I recommend that you do so. It will not be something I ever cover on this stream. So there you go. You can go do that on your own. So that is what would normally happen. Even if you were using a minimal build process, you would often come in here and add handmade.cpp onto the build line, and you compile it that way. I don't like to do that. I find that that just basically takes longer to compile. So what I do instead is I do something that a lot of people call the Unity build. And it's a little confusing because it has nothing to do with Unity, the game engine, which is what people probably think of when they hear Unity build. But actually what I am talking about is the concept that you just only have one conceptual translation unit in your entire project. And what that means is basically Win32 Handmade is the only file you will ever compile on Win32. And Linux_handmade.cpp is the only file you'll ever compile on Linux. Reasons that I like this. I like it because it means getting the build working on a new platform is absolutely as dumb simple as possible. You literally type the compiler and the platform file name and it builds. That's it. There's like nothing else that can go wrong. I mean, sometimes if you require these sort of things like I did here and you don't try to do automatic determination of the platform, then you have to be able to do that. That is really about it. I like how dumb simple that is. I like how it means that you won't spend any time fussing with your build environment. The other reason that I like it is it means you never have to forward declare anything if you don't want to. H files are largely optional at this point, because since everything is in the same translation unit, basically if you just stack things up in the order that you expect to call them, it kind of just works, and you can get rid of all the duplicate typing that you have to type for forward declarations. It's a minor benefit, but it helps. The other thing that I seem to notice about it is crazy fast compared to how long it takes to compile things not doing it this way. I feel like there's just a lot of startup time for the compiler, a lot of overhead in including things. I don't know. I don't pretend to know the reasons for that because I've never worked on a commercial compiler. So I couldn't tell you, but all I know is it is a lot faster to compile a single file than it is to compile lots of files. That just seems to be the case. And I have not found a situation so far where that hasn't been the case. So you get a speed win too, and I'm all for that. So that is what I did right here. Instead of doing basically putting Handmade in here, I stuck it in here. We're going to be getting a little more formal with how we do that, but for now, that's really all we need to do. And so that is pretty much how you would set up the build for now and forever. That's really the end of it. That is how I will be doing it pretty much till the end of the project, I suspect. Okay. So let's talk about the two philosophical branches we can go down, and I'll tell you the one I'm going to be going down so that you understand the differences and can see them. All right, so one way, and I'll start with the way that I think is more prevalent today, so that you can understand the way that most people, I think, do this. So one way to do the cross-platform code is basically to virtualize the operating system out to the game. Now, what do I mean by that? What I mean by that is that instead of thinking of the game as sort of an isolated entity and that the platform code is working with the game or any of these sorts of things, instead what you're thinking of is just literally abstracting the literal operation, the specific operation of the platform. Abstracting that into a virtual set of calls that your game can call as if it was running on that virtual operating system. So what that normally looks like is after you enter WinMain, for example, you will call game main, right? Well, you won't call it that way, but you'll call game main. And then inside handmade.cpp, you will have game main, okay? And then what will happen in game main is you will start calling the platform layer to do various things. Platform layer open window, and you will tell it to open a window for you, and you will get back a platform window, like this kind of a thing, okay? You will then say platform layer open sound device, or something like this, open sound device, right? And you will get back a sound device. And I'm making these names up, but this is basically it. You will then go through and essentially do all of the startup code that you would normally do for an operating system if you were writing in that operating system directly, but instead of ever actually calling an actual operating system and asking it for something, instead you are always calling a virtual operating system that you have made up in your head, right, and defined in some H file, and then it is doing the work behind the scenes necessary to do all the stuff on actual Windows, actual Linux, actual Mac OS X, right? You're actually calling all of those things, and it's doing the work behind the scenes to make it appear as if you were running on this magical operating system. At the end, you would have game shutdown, and game shutdown will do the same things. It will do platform close window, right? That sort of stuff. I don't know why I was calling this platform layer. That's not what I said it would do. You will be doing things like this, right? You will call platform close sound device, right? And hopefully this is all pretty understandable what this would be doing. Basically, if you look back at our Win32 Handmade, you can already sort of see what would happen. This platform open window call, we would go in here and we would take this code, right? This code here that opens a window. We would extract that code. We would put it inside the platform open window call. We would take the hwind. We would wrap that in this platform window struct, make it opaque. And then basically we would have a virtualized version of all the things that we did in Win32Handmade.cpp. Make sense? It's very straightforward to do. I don't think you would run into a lot of problems if you want to try this yourself. I feel like, there isn't a lot of nuance to it. It's fairly straightforward. So if you want to try that and that way sounds attractive to you, then you can go and give that a shot. Like I said, I do not want to be ideological about it, so I would not say don't do that. If that seems like the way that you would like to do it, you should give it a try. And it should be fairly straightforward. It's exactly what I just said. You take all of the things that you were going to do and you abstract them. Now, I'll give you a little hint in case you want to do this, since I won't be spending a lot of time talking about that method because we're not going to use it. You may ask, how do you return the opaque stuff, right? How do you do this platform window thing? Well, the way that you do that is actually pretty straightforward. You can do something like this inside handmade.h, right? You can call, in fact, I'll just go ahead and do one of these for you just so you can see. Because like I said, if you end up feeling more comfortable with this method, I highly encourage you to do that. You should always program in the idiom that feels most comfortable to you. You should not program in a way just because I said so or somebody else on the web said so. That's a poor reason to choose a particular way. So just in case you want to pick this method, I'm going to show you how to do a couple things in it. I think that's a good idea. That way people will be set up for success if they choose to go that route and don't have any experience with this. Okay, so if we were to do this, and we want to do the open window thing, right? We would do something like this. We would declare struct, but we wouldn't say how it is. So we'd basically just do a declaration. We would never define the struct. We would just declare it outside here. I'm gonna get rid of the platform load file because that doesn't actually exist anymore. That was just my example there. So we're gonna say platform open window, and maybe it passes, let's say, the title to the window that it wants to open. I don't know what it's going to pass here, but other stuff, right? Whatever you wanted. Maybe you want the dimensions to pass. Whatever you think you want to pass there, you pass. Okay. And then I have another thing, which is close, platform close window. And that's going to take that same window handle, right? That same window handle, and it's going to close the window.
So, hey, brother man, welcome back.
So what we do then is inside our Windows platform layer here, right? We would implement those by first defining the platform window in here, right? Because one of the interesting things that you have to remember is the Win32 code is only going to be compiled on Win32, and the Linux code is only going to be compiled on Linux. That means we can actually have two different definitions for platform window, right? We can have two totally different definitions for platform window that don't actually have to be the same. So we can, in our platform window here, right, we can store the hwin handle, right? This is the handle. And inside our Linux one, right?
I'm doing good. How about yourself?
In our Linux one, we do exactly the same stuff.
Isn't it like 3 a.m.? Oh no, I'm a bit distracted, that's all. Thinking about, I got a lot of things to do today after this. And I'm just, and plus, upgraded Zig. And can't get the build to run. There's some errors. So I've got to fix that too. Probably I can just clear cache. Nope, and the format doesn't work either. Yeah. Well, maybe I can just delete Zig out. Yeah. Maybe I'm using it wrong. Yeah, it doesn't really do anything. Don't know. I'll check it later.
Right? But instead, we would.
I have zero idea. Okay, I can give you some context. I mean, maybe you've heard of Handmade Hero. It's a series by Mr. Casey. It's, I think, from 2015. So he goes through how to build a game from scratch and basically builds the game engine too, I think. Now I'm not interested very much in making games, but I do like how he builds the tools around it. That's what I'm more in for. So that's like a rough idea of what he's doing here. It's pretty good. If you're into programming, you should give it a go. It's what to say. Yeah, it's a lot of fun, at least for me. So yeah, there you go. Now you're caught up. That's pretty much it. Okay, and also one small difference is he's building on Windows. I'm building on Linux and using Zig instead of C. Yeah, just because to do something different, I don't want to otherwise I know myself, I'll just copy what he does. So this way I have to go and figure out how to do the same in Linux.
Do whatever the X thing is here. I don't remember, but I think it's capital window or something like this, right? That's like, you know what? I think it's that. I could be wrong. In fact, on X, you may not even be able to do some of these things. You may not even be able to use window because I think they do some crazy stuff like that. I'm not sure.
Yeah, he's right.
I don't remember. I wrote my X platform code a while back and I haven't looked at it since. But point being, there's something that goes here, right? And it's whatever the X Windows platform handle is. So this is the X Windows window type would go right there, right? So then you just put the code in there, right? You create a new one of these, right? So you're going to have to allocate it, right? Whether with malloc or whatever you want to use for allocation. We'll be talking about allocations a lot, and I'll show you how I want to do them, but however you want to do your allocations is fine. So you allocate it here, right? And you make one of these things. This is the result. You then do all this code that you were going to do, and the create window, you know, this equals, the handle equals the result of create window here, right? And then you just return.
I don't know. I'm not really making the game. I don't know yet. Maybe I'll make it if I get into it later. I don't know. I'm thinking more of, I want to build a tool. What kind of tool? I don't know either. Basically, I don't know what to do, so I'm doing this. So I stream mainly to do like my side projects. I realized when I stream, I tend to finish my side projects. So yeah, so I don't know what my next side project is. So I'm here for like some inspiration through Handmade. And also like to understand how to build applications on desktop.
That, okay? And
no, I don't know. Like I said, I have no idea. I want to see. I'm gonna watch this at least. I don't know, maybe 50 or 100 of these episodes, maybe. And then I'm guessing along the way, I'll get an idea. Yeah. I work as a programmer.
And then in here, when you get a new one in, you just look, is it valid? If it is valid, you would do your close window right on it or whatever. You'd ask window to do it, and that'd be it. So it's really, really straightforward if you do want to do this. Basically, you just wrap up the types in your own opaque handle. In your platform non-specific part, you just don't tell them what it is. You don't let them know at all. They have no idea, so they can't accidentally use it and start creating platform-dependent code. And then on each platform, you define a version of that struct that encapsulates the things that you need, and you're done. And that's all there is to it. It's really nothing more complicated than that. So hopefully that makes some sense. We're not going to do that, but if you did want to do that, then you would be off to the races. So you know you're good to go at that point. So let me make sure we're back to normal here. I'm trying to get rid of some of this stuff. So that I don't leave old demo code around. Get rid of that, get rid of that, and now we are back to square one, I believe. Let's just verify that we are back to square one. We're still running right. Everyone is happy, I assume. Yes, it does appear to be. Why is that? Why are we going nuts there? That is not a good dead zone at all. Why are we scrolling like that? Oh, does it look like what's going on? Did you see how crazy that was scrolling? What was going on there? Oh, yeah, it looks like the controller just wasn't initialized yet, so it was giving back some I mean, it was pseudo-initialized? I don't know. It's kind of weird how these X-input joysticks behave. When we get to Windows shipping code, I wonder if we'll have to do some stuff there, or if my it may be just because we haven't implemented any dead zone handling or something, I don't know. Maybe it's nothing to get concerned about, but it was a little wonky. Point being, we don't need to care about that at the moment, though. All right, so hopefully that all made some good sense, and if you would like to go out and implement your platform layer that way, hopefully you can kind of see how that would happen. It's really not that complicated to do. You just start going. Okay, I don't actually like doing things that way. The reason that I don't like doing things that way is that it is a more expressive interface.
I don't know if it's dedication. I think it's just, I can't like help myself. It's kind of like an obsession. But yeah, I mean, it depends, right? If you find something you like, I think you are the same.
Excuse me, than necessary. And what do I mean by that? Well, an operating system is designed to do all sorts of things. It's designed for applications that want more than one window. It's designed for applications that don't want a window. It's designed for applications that will open windows, open windows again, close windows again, open windows again. It's designed for applications that show up in the start menu, that appear in the taskbar, that do all sorts of things like use the component object model and want to be able to embed themselves in other applications and use object linking and embedding, register themselves in the registry, integrate into the shell. An operating system supports a huge amount of flexibility, and one could argue that that's fine. We don't need to criticize the operating system for doing that. Maybe that's...
Yeah, 100%. I think you'll know when you find it. It's like you can't stop. I don't know. Thinking about it. I thought it would, like, after a few years, I wouldn't feel the same way. But I think I've been programming for now 5 years now. And I think it's just gotten worse. I think the more I understand and like the more I want to know, I think you'll find the same. And it's easy, like I'm not trying to do anything. It's just what I want to do.
The operating system's job. But when it comes to a game, we do have to ask ourselves, do we need that flexibility? Is our game going to be opening multiple windows? Is our game going to need to open and close windows, open and close them, open and close them, open and close them of its own volition, right? Not even in response to an operating system message where we could just handle it in the operating system layer, but does the game need to know that those things ever happened? Does our game need to even know what a window is? Does it care what a window is at all? Does it need to know about sound devices, or does it only want to give us back a stream of sound, right? And what I usually argue is that you don't want to add all that complexity to the platform layer if you don't have to. What I'd much rather do is define things the other way around. Instead of the platform layer being a series of services provided to the game that the game then constructs a running application out of in much the same way that a normal Win32 application would use the operating system directly, I prefer to think of the game as services to the operating system level to produce the graphics and sound necessary to play the game. Now let me show you what I mean by that. What I mean is that really, when we look at this platform layer that we've already written, there isn't much of a compelling reason to abstract any of it out of this code and allow it to be callable from the game layer. And in fact, you might actually argue that there are reasons not to do that. And those reasons are that when we actually start to tighten the ratchet on this platform code, there may be lots of very complicated logic that we need to do in order to most carefully adhere to the standards for that platform. There may be tons of Windows messages like device change that tells us we need to move to a different monitor at that time, right? There may be things like device removed, that the gamepad got unplugged and then replugged again, right? There may be all sorts of special things about like this device is a pen and so the pen should be treated this way but only in certain circumstances and depending on whether you're active at the time or not. If you think about all those things, they're different for every platform. Every platform is completely different when it comes to these sorts of things. There's a lot of very important differences. Compare and contrast something like Cocoa and the code that you write on Mac OS X with the code for, say, Linux. It's very, very different. And so what I would much rather do is just write all the operating system code and let it be all tangly and weird and do all the things that it needs to do specific to the operating system. And then the only
I'm guessing self-taught, or you went to college, etc. Yeah, I did go to college 10 years ago. No, maybe longer. And 12, 15 years ago. For computer science, but I didn't pay much attention. So I knew I did a bit of C for the first 2 years. Then the second two, I didn't pay attention at all. And after college, I decided to be a dive instructor. So I worked as a dive instructor for 6 years. And then I learned programming again the second time. And the second time, I sort of got it and then started enjoying it a lot more. I don't say I was self-taught because I found this community called Code3 where like software engineers teach like other engineers, and they basically give you things to do and review your code. So yeah, so I learned it through there, I would say. The second time I really understood it. The first time, not so much. And not because like college was bad. I think I didn't care to pay that much attention.
Thing the game ever does is respond to a few very simple requests, which are, give me the stuff you want to draw, give me the sound you want to play, and here is the user's input, right? If you think about it, there's really only 3 things that it needs to provide. And then on the back channel, there's really only 2 things you ever need to provide. Please send this out the network for me, and I need to read or write from a file now. Not a whole lot there, right? So what I would argue is you can drastically simplify the degree to which your platform layer inherits the complexity of its operating system by not forcing it to pass that complexity onto the game and round trip all of the logical operations through it. Hopefully that makes some sense. Now I'm going to show you how we do that. Basically, all we have to do is isolate a few specific locations in the code where the platform layer wants services from the game, and then isolate a few specific parts in the game where the game wants services from the platform layer. Okay, so for example, when we are in here, right, you will notice that we have a while loop, and this is our global running loop that we wrote. We process our messages here, we get the input from the gamepad here, right? And this was test code, but it's not that far from being regular code that we could ship. There's things we would definitely do to it, but it's sort of getting there, right? Now you'll see I've already kind of suggested to you what then should go on. Well, this right here, render weird gradient, that's our renderer, right? That's the thing that we rendered. Now we just have a faux thing sitting in there, but that's basically the thing that renders for the game. So I can just say game update and render right here and say this is where it's going to do its updating and rendering, right? And what I expect this to do right here, I expect this guy, oops, I'm going to put a little note in here, right? Note Casey, services that the game provides to the platform layer, right? Game update and render is one of them. And I don't even know if we're going to need any more of them at the moment. That may be it. Maybe there'll be some more, right? And then here we're going to have services that the platform layer provides to the game, right? And we're not even going to fill those in yet because that's stuff like load file, and like I think I've said before, if you happen to read my blog, I'm a big fan of semantic compression, or basically compression-oriented programming, which means you should never write something in before you actually have it working, and you should never like presuppose that an API works a particular way. You should always pull out and develop the API from the ground up. So we happen to know this is exactly where we...
It's a good read, the article. I read it. Semantic compression. Yeah, it's fun. It's pretty good. I read it. Very practical.
We would want to do our stuff, so I'm okay with saying that. Game update and render, but then after that, I think we're pretty much done with that. I don't want to presuppose anymore. So I should actually almost say to do here. We'll add those in as we go. Okay, so basically what we want to do here is we want to say the game update and render, right? We want that to basically do the rendering into that bitmap that we set up. So we should probably pass the bitmap here to the game so we can draw into it, right? And then we also want to pass it the sound. We want to basically pass it a buffer so we can get sound back, the sound that we're going to play.
Hey, get some sleep, Redmond. Thank you for hanging out. I'll see you later.
For this buffer, right?
You have a good day too.
So we're going to do those two things. And then at the end of it, it should pretty much do the output. We've got all our output working. We've got some timing code in here. We should probably take this stuff out for now because we don't actually care about this printf at all. So I'll get rid of that for now. There we go. I don't know what display the value here is. That's some old comment. Comments are always out of date. As Jonathan Blow says, comments are always out of date. Wow, we got a lot of comments that are out of date here. Sorry to jump in here. I think Iker Murga wrote in and was mentioning these. We did change to using a lower latency already. We already did that. Yeah. Oops. Oops. Yeah. Let's see. Do we have sine wave? Yeah, switch to a sine wave. Yeah, we've got a lot of things in here. We did switch to sine wave. We're not taking our to-dos out after we actually do them. We should start to look for that. But anyway, so, okay. Sorry, back to the story as it goes. Sometimes you got to stop and just go, what's going on in there? What is going on in there? All right, so basically, all we need to do is we need to have our game update and render. Basically needs to provide us a new bitmap and a new piece of sound, and it needs to take in the input, right? So we need to pass it essentially 3 things, right? Game update and render needs to take 3 things. It needs to take the input, right? The controller keyboard input, right? It needs to take the bitmap to output, right? And it needs to take the sound to output, right? It needs to take the sound buffer, the bitmap buffer. I guess I should say to use instead of to output, right? So it's going to take the controller keyboard input in. And you know what? Let's call it 4.
I'm from India. Yeah. From Kerala, south of India.
Things. Let's Spanish Inquisition that. Because we're also going to need timing. Because if you were doing a locked timer, if you were going to have a game that had a fixed frame rate, so it always ran at 60 frames a second, then that's all you would need, right? You wouldn't pass any timing information into it. But in this particular case, since we are not doing that, we're going to do a flexible frame rate for the game. We need to pass in some timing information so the game has any idea what's going on. So at the outset, we pretty much only need these things. Now this may, I'm going to put a note in here. This may expand in the future to like a sound on separate thread, etc. In the future, we may want this to be more complicated. The calls may go from 1 to say 3 or something, right? Because what we may want to do in the future is we may want to have it such that we can have sound run on a different thread and get updated asynchronously or something like this. And so
yeah, that's exactly what I need to do.
We may want to have the game support calling it back in less of a monolithic fashion. But we're not going to do that until we actually know that we need it. All right. So basically all we're going to do is if we run the game now, we can actually, we've had a regression essentially, right? We've gone backwards in functionality if we run the game now. And the reason is because I took out our call to render
Yeah, no fart at all.
gradient, correct? Like if I look at this, there's no more gradient because we're not calling it anymore. So basically what I want to do, just to end the stream today, now that we've kind of seen the way we're doing platform services, is I would like to basically pull out our first piece of platform independent code, which is render weird gradient. Because if you look at it, you will notice that there is almost nothing about it.
Yep. See you later. Have a good night.
That is platform specific. This Win32 off-screen buffer is really the only part of it which that is true. So I'm going to go ahead and just pull that straight out, right? I'm going to go ahead in here and drop into my handmade.cpp, and I'm going to stick that in here. And you can see the only thing that we really need to do is we need to change this Win32 specific thing to a non-Win32 specific thing, right? So all we really need to do is go here and take this struct, right? This struct that we had, and we need to make that something that is not platform specific. And really, it almost already is, right? It almost already is something that is completely platform non-specific. So if we take a very trivial step here, right? We do game off screen buffer. We've got our blue offset and our green offset there, right? Got game off screen buffer, and we pass the buffer in to this. Then we will be able, and I'm not saying this is how it should necessarily go in the final thing, but we are sort of starting to get, usually code goes through a couple of transformations first, so just be aware of that, but you can kind of see what I'm doing here. We'll start, actually I guess I want to do int blue offset, int green offset. Basically what I want to do is just make it so, 5-minute warning, almost out of time. Good thing we're almost done. I want to make it so that we can at least get something rendering before the end of the stream, so that you can see the first step in platform independence. So basically all I need to do now is make it so I have one of these to pass. Oops, get rid of those ints. So really all I need to do is make sure that I can pass one of those to this. And we can even do that in place here. We can just say, okay, game off screen buffer is some kind of buffer. The buffer has some memory, right? That memory comes from our Win30 screw off screen buffer. We've got the width, we've got the height, we've got the pitch, right? And where were those guys? Those guys were in our, where did it go? It's in our globals here. Darn you, 5-minute warning, you're using up my screen real estate. Global back buffer. That was what I was looking for. All right, so global back buffer dot memory, global back buffer dot width, and dot height, like so. Just pulling those out there should be good. And then we just pass the address of that, and there we go. Now, if I run this, you will note that we're almost back to feature parity. We've almost got it back to the place where we had it before. Now, we can achieve feature parity pretty easily by passing blue offset and green offset here, right? If we wanted to do that, we could easily do that. So basically, if we said for some reason that our thing had this, then we could easily have feature parity, which we should probably do just for the end of the stream, just for fun, like that. Let's see here. What is it actually called? What is it called? I thought it was blue offset and green offset, but apparently it is not that. It's X offset and Y offset, right? Because we were doing the two different ones. X offset and Y offset. So X offset, Y offset. Okay, render that. And now we should have back our controller, and we do. Okay, so I hope you can see how easy that is, right? It's very, very straightforward. That was not like a sleight of hand or anything for those of you who are unfamiliar with platform independent programming. Really, it is that simple. We'll have to do a little bit more here. We're going to get a little fancier tomorrow, obviously. But it is really that simple. All you have to do is define a rigid boundary and then move things across the boundary from the specific side to the non-specific side as necessary. And pretty soon you'll be at the point where almost all the code you write will be on the non-specific side anyway. You won't need to write them in Windows. But that's really all there is to it. It is not very difficult to make very clean, very nice cross-platform code. A lot of people don't. But that, I think, is literally just because they haven't had the experience and don't know just how easy it is, because it actually is pretty darn easy if you just have a little bit of discipline to keep it that way pretty much through the entire project. So there's that. So basically what we've done is we've essentially nuked our render weird gradient call, right? It's gone now. So that is one nice big chunk of code that got moved out, and we are left with mostly code that's specific. The sine wave will be the one that we'll do tomorrow probably, and then we'll look at moving the input as well. But we are well on our way here at the end of the stream on day 11 to essentially having cross-platform game setup ready to go. And again, this will allow basically anyone who's trying to follow us on Linux or Mac OS X to go use, oh, you know what? This might be a good time just before we get to the Q&A to give a shout out to David Gao, who has been doing some porting work. If you go to the forums, there is under coding resources already, even though this section is kind of under construction. There is a platform page, and David Gao has contributed a little handmade penguin thing. Basically what he does is he follows the stream and he shows you how to do the same stuff using the simple direct media layer, which is basically a cross-platform abstraction of windowing systems so that you can run on Mac OS X and Linux and so on. It is a very well-respected library, the SDL is. A lot of people ship games on it. So if you were looking for a library to use to help you run on a platform that you didn't understand, or if you just want to use an abstraction layer in general, that is probably a decent one to use. But anyway, point being, he has ported that stuff, and again, you can get to that link pretty easily just going to coding resources. It's right there. So if you are following along at home, we are basically at the end of this week. We will probably have pulled most things out, and we will be in platform non-specific land, so you can follow along at home exactly like you could if you were on Windows. So hopefully That has given you a little bit of a background in the philosophy of cross-platform development and how it should work. I've given you 3 different ways you could do it. I've recommended one of them, but you are welcome to look at the other 2 and see what you think of them yourself. Practice them a little, maybe, see what you think, and come to your own conclusion. We will be continuing with this tomorrow at 8 p.m., and I think now might be a good time to go into the Q&A. Obviously, as always, if you would like to have a copy of the source, you can pre-order it. You can pre-order it from handmadehero.org right here if you'd like to, and that will get you access to the source code. I push it basically right after the stream every night, so right away you can get access to it. And we will be putting the art assets up as part of this pre-order as well, so that if you want to follow along with the art assets we use once we start doing graphics and sound and stuff, they'll be in there too. And I think that's about it. I've got some notes that I wanted to talk about in the Q&A, just some cleanup from before, but I will look at questions first, and we will talk about those as time permits. Okay.
Just have a look at the Q&A, see if I find something. Okay. Right. I did see the STL thing. But I wanted to just find out how it works without using a library. Yeah, but if I wanted to switch to STL, it'd be very easy. And I think STL also handles sound and input. Yeah, should be much simpler. But for now, it's fine. I can use Pulse Audio and X11. Alright, now I gotta fix this. I've created Zig version. But now, I can't get it to build. Let me have a look at, I just cleared it. Zig build on. This is a local Zig standard system. Use Zig format. Okay, but this is. Zig format to auto upgrade. Zig format. Hmm. In place, arguments can be files or directories which are searched recursively. Zig format file. Says or directories. Oh, okay, I see. Maybe I gotta run it on. It's not my file, is it? So I gotta run Zig format. This could go wrong. Local Zig lib. Okay. Use the local lib, compile RT, modifies or modifier forces time evaluation. Standard built-in is missing assembly. Hang on, let me just check the change log. Line dot. I think as of now, I don't use the IO writer. I did see that one. Let me clear my cache too. Clear that, and yeah, no. Run. Parents. Trace. Extended. Built. Missing assembly. I'm not sure what I'm missing. I don't understand the error. Yeah, still here. Not sure what this is. Able to evaluate content of expression call. Let's just Google it. Ha. Okay, I guess. Oh no, this is an old one. Okay. How do you update? Hang on. Maybe did I install it wrong? User local sake. No, I did. Yeah. Maybe I should just reinstall it. I think I can fix this off stream. I don't see the point of streaming. I gotta fix my Zig updates. I think I messed up the installation or something. Not sure. I think the library still might be old. Can't remember if maybe I just copied the binary. I'll have a look. Anyway, I think that's probably it for today. Got a long day ahead. But yeah, I'll see you back here tomorrow. And probably get Zig to build again. And start the refactor. Oh, and I still gotta check if sound works. Okay, a few things to do. Do it tomorrow. Alright. Well, it's quite a short stream. Been a while since it's been this short. Anyway, thank you for hanging out. I'll be back here tomorrow.